As such, attendance policy, when we have physical classes, there was an attendance policy we used to follow. But for online classes, we'll follow as per the institute norms, whatever will be decided by the Senate. But I will recommend that if you can attend the classes regularly and do the practical, whatever best possible way we can do that, I think you will enjoy the course. That is only recommendation I have for all of you. Now, when we talk about computer-aided manufacturing, this is something has been listed in the course of content, the course of study basically. And we are supposed to understand as a part of learning in this course that what is the role of the computers in manufacturing. And this course has been designed, I think, long back, and when people are teaching computer-aided manufacturing, in fact, I have also studied this course at IIT Kanpur. There are various aspects of learning how these computers are playing a role in manufacturing. And the most important part is that how the technology is evolving. And certainly when the structure of this course being designed, the computers were just started and then introduced in the manufacturing. But these days, you will find that computers are not just computers in the form that we understand initially. Now, these days we'll come to know about a lot of embedded computers, controllers, everything is basically coming to play a role in the manufacturing. So when we discussed about the role of computers, certainly we'll talk about the computing systems that you understand, but let's try to understand beyond the basic screen, desktop, and maybe the laptop. We can just look at the systems beyond these kind of computers. So when I am just indicating toward that, it's basically the embedded controllers and the PLCs as well also included into this. Now, when the computers started playing their role in manufacturing, certainly there's a lot of changes happens, there are a lot of evolutions happens, the way the manufacturing is being performed, and mainly in terms of how the machines are being controlled by the computers. So that is how we'll try to understand the computer controlled machines. And as you all understand, all sort of machines these days are, most of the machines are having some sort of controller embedded into them. Either it's a motion controller or the logic controller, and otherwise we'll also be having some kind of an embedded controllers these days coming into these machines. And when we talk about the recent developments, and I'm sure that all of you are familiar with the developments happening around in the domain of manufacturing, and we talk about the smart manufacturing or industry 4.0. So that way, we need to understand the perspective very well. What is the role of computers in the manufacturing? That is how I will be covering the content in this course. Digital fabrication, certainly all governed by these kind of computer controlled machines. So we need to understand that aspect as well. Then there's a aspect mentioned about the modeling and the product life cycle modeling and the geometric modeling for manufacturing, and what kind of a virtual and distributed manufacturing environment is being developed over a period of time. So we'll touch upon that aspect as well. But most importantly, the red color topics I have added first time in this course, because I would like to get all of you are familiar with the new developments happening in the domain of Industry 4.0. So we'll be talking about industrial Internet of Things. We'll be talking about the technologies like augmented reality, machine learning, digital twin, and what is the role of robotics in manufacturing. So let's try to cover up the broad perspective in this course. So it'll not be just limiting to what is being available in the books, but I will try to also give you a wider perspective in terms of the latest development happening around industry. So this is what the course objectives that we took, and certainly the course content detail is just mentioned around these topics only. But the topics that 7, 8, 9, 10, 11 is being added, and I will be covering in this course. And certainly that I have distributed over the 42 hours of lecture. So in fact, I have prepared a detailed lecture by lecture course plan also. So I will be covering at least the basics and introduction of the computer-aided manufacturing. Then we'll talk about the computer-controlled machines and how you will be programming these computer-controlled machines. So when it comes to program a CNC machine, it's not just a part program that most of you understand. But we will also be talking about the controller or the logic controller that is working, or the motion controller, how it will be controlling the machines. So when you write a particular instruction of the code, how that code is being executed by the computer. So we'll understand all those aspects. And then we'll also be talking about the robotics, what kind of simulation environment is available, how you can design a robotic manufacturing cell. We'll talk about the Industry 4.0 technologies, product life cycle we are talking about. So that's how I will try to cover up most of these content in the 42-hour lectures. I will also be trying to give you a glance of all these technologies, at least some kind of an hands-on learning, whatever we will be discussing in the class, so that you will also be able to perform all these experiments on your own. So when we talk about programming CNC machines, certainly uh, because you are not coming physically to the lab, so we'll take help of some of the simulation software so that you'll get an idea about that. So you'll use a CAM software, master CAM, that is available, so that you will be able to try out your program and run it for the CNC machines. I will also be understanding the PLC programming, that is the logical control. So you'll understand what exactly inside the controller. So as an operator, it's fine that you understand that you have to download a part program and then you will just run the command and the machine will start preparing a component for you. But as an engineer, we also need to understand means how the instructions of the code are being executed inside the machine and how the relative motion between the workpiece and the tool happens so that it will generate a particular shape. So we'll try to understand all those aspects in this course. And as I was mentioning, I will also be giving you a hands-on on the some of the environment or the softwares that are helpful in implementing Industry 4.0. So we'll be conducting some labs on the commercial platforms available for implementing IIoT, AR if it is possible. Let's see that how quickly you will be able to create those augmented reality applications for manufacturing. We'll also be giving you a quick idea about the environment available for implementing machine learning for manufacturing and robotics. And certainly I look forward that you will try to put all these learning together in the form of a term project. So that is the idea for 28 hours of the lab plan. You're free to give your inputs at any point of time. And if you want to interrupt me and ask something, please raise your hand and then I will ask you to ask the question. In terms of books, these are the books available and used by people to teach this course, computer-aided manufacturing. So you will come across some of the content that I will be covering in the slide taken from some of these books. But there is something beyond these books also, because most of these books are being written almost 10 years, 15 years back actually. So fundamentals certainly you will get from these books, but the latest developments, there's no book available as such. So I will be just covering the content from the various sources. Some information is coming from the manufacturers or the developers of these software applications. So that is the quick introduction about this. So course outline, any doubt, any question you have about this course outline? Otherwise, I will go to the introduction part.
Hello, sir.
Yes, yes.
Sir, we will be having 2 minors or 1, because the previous semester we only had 1 minor.
So let me see, because I have not seen what is the Senate ruling right now. If that will be 1, then I will just merge minor 1 and 2 together. No issue.
Okay, sir. Thank you, sir.
So that I will follow with the institute ruling, what is applicable right now in the online semester.
Sir, also the lab component of other courses are not being conducted, and we are being told that they will be held in the summer semester.
So that is not compulsory for all the courses. Wherever we will be able to manage to conduct the lab, we will do that. So it means for this course, we will be conducting all the labs in this semester only.
So it will be online only?
It will be online.
Okay.
So we have a sufficient software environment to do all the experiments in the lab, and some of the demonstration can also be shown to you. And if the later semester permits and you will be on the campus, then we will at least conduct some of the physical experiments for you also. But most of the computer-aided manufacturing and learning these days is conducted very easily on the software platform. So we will be giving you in a glance of all these software environments, how to do that. So we will be doing labs on the Mastercam. We'll be doing labs on the PLC programming, and that can be easily done remotely. And so we'll give you access to the hardware. We'll also be giving an access to the systems where these softwares are installed. So that's how Paras and Nitin are there to help you while conducting the lab. And we are conducting this lab, I think last year for almost 150 students in the BTech, and they have done their labs for the course that I used to teach, CAM and automation. So I don't see that there's much difficulty coming as such. Similarly, for the IIoT, the robotics applications, so most of the softwares we have where we can run the simulations and we can check the outcome, and then certainly there's a lot of learning happening with the help of software itself. Fine. Good. Any question?
No, sir.
Fine. So let's start the course with an introduction part, and let's try to understand the whole manufacturing with the quick understanding of a product life cycle. So whenever you are thinking of manufacturing, certainly there is an idea to manufacture a product, and how you will get that idea, from where the idea is coming to manufacture a product. Can anyone say something?
Customer requirement.
Customer requirements, right. So it's a very important part. Whenever we manufacture something, certainly the initial requirements are coming from the customer. So the product life cycle start from the requirement of a customer. Either it will be directly given to you, or sometimes we conceive the idea of a product and then we'll start the manufacturing process. So that's how let's try to understand. So customer requirements to be captured first. So whether you will be defining the customer requirements for the new product, or customer will be sharing his requirement with you to start the production activity. So product life cycle start with the customer requirement, and then we'll have what you will do with the customer requirement. If it is a new product, then you have to work on the concept of the product. So conceptual design has to happen based on the customer requirement. And then if it is in a previous product and there's a minor modification on the existing product, so customer may place the requirement for a new product. Customer may also request you to make something which is already in the production. So sometimes there's a new model of the product coming up, or there may be a repeat production of the old product. So that is how, if it is an old product, then we will not go into the product concept and the design activity. But if it is a new product, then you will be working on the product concept. Why I'm explaining this product life cycle? Because we need to understand where exactly computer is helping you in performing those activities. So because this slide, we will be just discussing the conventional way of doing the activity. Maybe I think let's say that around 20 years back. So let's see that how you will be capturing the customer requirement. You will be meeting the customer. You will be discussing the product idea, or you will also be listening what the customer requires. Then certainly he will give his input, and you will be recording that input somewhere in the paper. Then when it comes to the product concept, then you will be preparing the product concept with the help of the sketches. And that is how normally you start conceiving about the product idea. And then you do multiple iterations before you just start the design activity. So after the product concept is being finalized and discussed, then you will be going into the design engineering. So after the product concept, so what is the difference between the product concept building and the design engineering? Can anyone tell on that? When I say product concept building, and when I say design engineering, what is the difference?
So product concept is basically the idea of which we are going to make a product, but design engineering is basically the on paper dimensions or the models of the idea.
Correct. So finally, basically, when we look forward for the design, we will be doing the analysis of the design. We will be finalizing the dimensions of the product. So based on the dimensions, you will be analyzing, you will be finalizing the material part, what kind of tolerances are required. All these specifications are finalized as a part of design engineering, right? So after the design engineering, you will be getting in a final manufacturing drawings actually. That is the important part over here. so that you will release the drawings and your manufacturing activity starts after this. So once a drawing is being available in the factory, and then the manufacturing people will start working on those drawings. So after the design, people release the manufacturing drawings. What is the first activity you will do? So shall I take the drawing and immediately go to the machine and pick up the raw material and start the manufacturing? Or if you, some of you might have seen the production activity in the factories also, maybe you might have visited as a part of your previous degree programs, or you might have worked somewhere. So what you will do with the manufacturing drawing? How I shall start the manufacturing process? Anyone?
So the material of the material, basic material which is required, or from which we are going to manufacture.
Correct.
Selection of material.
No, selection of material has already been done in the design engineering. So you are not selecting now, because once you get a manufacturing drawing, material is already specified on the drawing itself. Only thing what you will be doing, you will be procuring that material. Is that right?
Oh, yes, sir.
And then, so you procure raw material. What else? Let's discuss. Let's everyone participate. Otherwise, I will just read out the name and then I can ask and you can just respond to that. That will also be fine if you're not coming voluntarily. So
might
because
be listing down the
background on the manufacturing, I am sure that because as a part of the basic workshop technology or manufacturing, you have already gone through that kind of learning earlier. So let's not just have one person responding to all the question every time. I just ask someone. So Anuj Seni, can you just let me know what you will do with the manufacturing drawing? How you will start the manufacturing activity?
Sir, after getting the manufacturing drawings, we will try to find out what are the ways to manufacture that product, what processes we do we need.
And what we call it actually, what we call that activity?
So scheduling the...
No, scheduling comes later. So what Anuj was explaining is something different. Can anyone tell the name? We call it process planning. Process planning actually. So you will be then breaking down the sequence of activities, preparing a process sheet, and then you will be specifying which machine tool to be used, which cutter or which tool to be used, and then you will be releasing that sheet to the operators basically. So that will have a step that you will be doing a turning, you will be doing milling, you will be doing drilling. So all the breakdown of the sequence of the manufacturing processes are to be listed onto that sheet. That is how the next thing you will do, the process planning for this. So once you plan for the process, then only you will be getting an idea, I mean, what all machines are required, which all tools are required. And certainly when you are going to do in a factory, then you will be going to a different divisions or different shops, basically where the activity is to be done. So it may be some manufacturing activity in terms of machining or the welding or the sheet metal. So that all details will come out when you do the process planning thing. Fine. So after manufacturing drawing, you will study the drawing. So as a manufacturing engineer, you have to come out with the idea means how I will manufacture this particular component, and you'll prepare the process plan, and the process sheet should be prepared after this. And then certainly, as we were discussing, we need to have a raw material. But other than the raw material, now once you prepare the process sheet, you will get an idea means what kind of tools are required actually, what kind of jigs and fixtures are required. Which machine to be utilized actually. So if the tools, jigs and fixtures, everything is available or not available, then you have to manage for that. And that is what is known as the production planning. And production planning, once you did the production planning, then scheduling is actually when exactly you want to make that part, or when you want to perform that process. Because the machines in the factory are not always available to you. There's always some kind of job running. So whenever you are starting a manufacturing of a particular product that you want to take it up, you have to schedule it actually. You have to schedule and you have to basically reserve some time of those machines so that you can do the production activity. So that is the role of a manufacturing production planning. We call it in a production planning. So if you see here, yeah. So production planning, there are multiple activities to be done as a part of the planning. So you will be doing the material requirement planning. You will be procuring the parts or the raw material. Then you will also be preparing the process plan of this activity itself. So once you do the process planning, then you do the production planning. And once you do the scheduling also be coming as a part of this only. So once you have scheduled the job, then exactly the activity will start. Then actual manufacturing activity will start. So in that case, if you see here, then you will be utilizing the machines, and then you will be performing the operations, and the part is being produced. So then individual components are being produced. Later on, the assembly will happen, and then finally you will be making the part that has been designed. Now, you can't leave production just to perform the activity, and later on you'll realize that the part is as per the design requirement or not. So what you will be doing, you will be continuously checking the quality of the component. So while the production is going on, you will also be doing the quality control over here. So that on each machine or during the each process, the quality has to be controlled. So that is how the part drawings will be there. So apart from the assembly drawing, you will also have a part drawing specified with the required tolerances, the surface finished, and then so that whenever you are going to assemble the final product, there will not be any issue. So that's how the quality control is very important part over here. So it plays its role continuously during the production activity, and finally once your product is manufactured with the right quality as per the design specification, then it will be delivered to the customer and it will be dispatched. So that is how the product life cycle works. And the days when the computers were not there, when the controllers were not there, when the machines are the conventional machines, then we need to visualize how we used to do these operations or these activities. So certainly all of you, I'm not sure whether you have gone through the preparation of the drawings in your engineering courses. We always used to do a drafter and the sheet, and then we'll draw those drawings ourselves. And these days, we are not going the conventional way. We will be designing the complete product differently, and then we are using a lot of computer resources basically to do these activities. So even for all these activities, so we need to understand where the computers are playing a role in the complete product life cycle. So that's an important part to understand in the while we are trying to understand the CAM. So is this product life cycle clear to all of you? Because we will be discussing in a very important aspect of this, what all time component you will be spending during this product life cycle. So in fact, there's a time T1 being spent actually on the raw material, that is during the production. But that is not the only time that will be spent during the product life cycle. So each product will be taking a T1 time while the operations are being performed on that particular product. But there's a time that is being consumed for production planning, that is the T2, and there's a time T3 which has been spent during the design of the product and building the concept of the product. So this T1, T2, T3 will take up subsequently in the discussion, but these are very important time component to understand when we talk about whether it's a computer-aided manufacturing or automation, or when we talk about smart manufacturing. Now, when we talk about the role of computers, let's try to see that. So same block diagrams I just put differently. Let's revise that how we will do the activities with the computers. So now everyone has to tell me that where exactly you are using, because now we are not studying this thing first time. You already heard about some of these technologies earlier also. So where exactly I will be using computer, and which activity is being done on the computers now. So let me ask Kumar Vishis. So in this product life cycle, so where you see the role for the computers today, and people are already using them.
So drafting.
Yeah, drafting certainly. So drafting, and before drafting, what you
So
will do?
designing
Designing, correct. So earlier, whenever, I'm not sure whether you have seen those duration or the time, people are drawing everything on the AutoCAD actually. So that was the drafting tool. These days, we are not doing drafting as such because our CAD models are sufficient. Once you perform the design engineering, the the surface models are being or the solid models are being prepared, and the drafting can be done easily out of that. So you are not doing the complete sketching of the product. It will be coming out from the CAD 3D design itself or the 3D model itself. So certainly we'll see a lot of CAD softwares as well as the hardware is available to perform all the first three activities here. So if you can see here, when I talk about the product concept over here, so starting from the product concept, engineering, design, and drafting. So we'll find there are common softwares for performing these activities. So whether you take an example of a SolidWorks or Creo or NX, I don't know what all CAD softwares are available additionally, but you will be able to conceptualize the product on the same environment using a computer. So a lot of graphics is available today, and a lot of innovative softwares are available to try out all those product concepts. So people are no more just doing the paper and pen based sketching or the pencil sketching. They are now utilizing these computing resources to do a product concept. And then it will be designed on the similar environment. So you will be having a CAD softwares to do the design engineering. You have an analysis software to perform the analysis on that. And finally, once you finalize your design, you will take out the drawings out of that. That's how the drafting activity is coming as a part of this CAD environment itself. So once you generate the drawings out of this, that's the drafting activity being done. So if you see here in this computer aided design and drafting, so you have utilized the computer resources over here to do the product concept building, design engineering, and drafting. Now, similarly for other activities, you have a computer aided process planning. Now, this is a very important part. Normally, it requires a lot of knowledge, basically, or I should say the experience to prepare a process plan. You should have a sufficient understanding of a manufacturing processes, capabilities, limitations as such. Then only you can define that what process to be performed on to make this particular product. So if a drawing is being given to you, you have to understand what all operations are required to give that particular shape. And then accordingly, you will be doing the process planning. So this activity is a very important activity, and only the experienced people are able to prepare a process sheet and process plan. So with the help of computers, because many products have a similarities actually. So if I see there's an axisymmetric component and the cylindrical shapes are being there, then I can understand, yeah, these are the operations that can be done on a lathe machines, and the turning is the process that can be performed. And then you can define what are the process parameters to be maintained to get the right quality and the right dimension tolerances. So that activity is now also be done with the help of a computer actually. So you will have a expert systems or the process planning softwares which will be either guiding you step by step. So once you see the prismatic component, and then you will see that how the shape is being generated, it will recommend that actually the softwares will be recommending you that you can select this process, this particular tool can be selected. So that way, for the similar components, there are software environments are available which will generate a process plan. It will be either aiding you or it will be generating a complete process plan for that. And then later on, you do minor modifications to prepare the process sheet. So computers are also playing an important role over here, which also it means that it capture all the experience gained during the manufacturing to prepare that process plan. And a very important activity for manufacturing that is being done here. So anyone who is now able to operate that software can generate the process plans. It doesn't require that 20-30 years of experience to come out with the ideas. So that is how the computer aided process planning is being done. Similarly, because there are a lot of resources are there actually to plan actually. So even to do the production scheduling, you need to do a lot of resource understanding their availability. All the data should be available so that you can take a decision at much faster way. So again, there's a lot of use of computers over here. So computerized scheduling, material resource planning, shop floor control, all can be done with the help of the computers. And certainly then we'll talk about the production activity, and that is what we normally understand when we talk about automations. We are talking about the role of computers while the production is happening. The rest of the activities are done before we actually start manufacturing. So in this case, you already seen the computer controlled machines. Robots are also there. Many assembly lines are being computer controlled these days. Most of the equipments are being computer controlled, whether it's in a furnace, whether it's in a machining, whether it's a welding. So you will find the computers are nowadays available everywhere. So that is how a lot of use of computers in the actual production process. And then you also have computer-aided quality control. So there are equipments available which are also using a computers to calculate some of the dimensions, parameters, checking the quality, recording the quality. Either it's an inline inspection or you will be performing an inspection after the product is being prepared. So all that data is now being captured and recorded in the computers, and computer will also be helping you fitting some of the geometries. For example, in the CMM, actually, you just pick up the certain important points and with the help of a touch probe, and then the computer will calculate the geometry and give you the idea, means what's the quality coming out. So that way computers are also used for quality control. So this is the way you can see that certainly when the branch of computer manufacturing or the stream or understanding of CAM has been built up, people have not seen or may not have visualized that computers will be coming so much into the production activity. But today you can't imagine any activity happening without the help of a computer. So that's how it's very important to understand. The role of computers are changing. Initially, they are coming as an aid to the people to do these activities. But today, some of the decision making, some of the analysis are being done by the computers themselves. So that is how we will be under. So when we talk about the smart manufacturing or the industry 4.0, we'll see there's a lot of role for a computers or the cyber physical connect that is happening as a part of smart manufacturing. So we'll be understanding that. In fact, the customers and the market, the data is also very important part. In fact, computers are playing a very important role for capturing that information as well. So these days, you might have seen that people are going with a handheld devices or maybe using their iPhones or the Android devices to capture the requirements also. The advantage is that the moment you punch in the requirement from the customer, the data is available at the factory, and then they can immediately start utilizing that information. So that's how the use of computers are also seen in capturing the data from the customers as well. These days, even sensors are integrated. So I will explain you all those things when we discuss a little bit on the smart manufacturing, how the data from the user is being utilized to start the manufacturing or even the product concept part. So all that has been implemented this. So when we talk about use of computers in the whole product life cycle, we will be looking forward for a much broader implementation than just what was defined in the books which was written 10-15 years back. Because these days that these technologies are changing so fast, we have to just understand the pace of that implementation, and that is how you will be keeping yourself familiar with these new developments. So when we talk about the automation and smart manufacturing, and certainly we are talking about the use of computers, our idea is that we should reduce the various time elements in the product life cycle. So now I was explaining the 3 time elements, T1, T2, and T3 that you have seen in the previous slide. I will discuss those time, and then we'll understand which is important in automation and which is important in the smart manufacturing, and where computer aided manufacturing will help you in reducing that particular time component. So when we talk about the automation, let's try to understand, because automation and CAM and the computer aided manufacturing, they're all related. So we need to understand what exactly I will be reducing with which type of technology. So when we talk about the automation technologies, we will be talking about the technologies that will be directly integrated into the machines, which will be transforming the raw material into a product. So where the actual production is happening, there we will be integrating the automation technologies. So if you see the 3 time components we have discussed, so T1 is the actual time that is being spent on the product while the manufacturing happens. So there we will be focusing more on the implementation of the automation technologies, how we can combine the multiple operations, how the multiple tool changers can take care of that, so the different machining requirement can be integrated into the automation itself. So that is the way we need to see the role of automation technologies, mainly to reduce T1. So whatever is happening, so you will be reducing how much time is spent per product. Actually, that is very important, because if you are going to make 1 lakh products or 10,000 products, that time is very critical there. So if you will be doing a mass production activities, you have to reduce the T1, the time spent. Even if you will be able to save 5 seconds on a particular product, you will be saving a lot when you are going to produce such a large volume. So automation technologies are helping you in reducing T1. So our emphasis is always on the technologies that will help us in reducing the T1. There's a time spent on. So that's how we will be using most of these pneumatics, hydraulics, electropneumatics, and the logical controllers, the PLCs are basically utilized. So these are the all automation technologies that will be helping us in reducing the time component T1. And when we talk about the smart manufacturing, because that's what is more relevant today, it's not just a mass production, because today we are talking about the customized manufacturing, and we are talking about so when we talk about batch size of one or just a one component of its own type, then it is very important, means how much time you are spending on designing that component, how much time you will be spend on customizing the design of that component, or how much time you will spend in procuring the material, or just preparation for the manufacturing. So T2 and T3, if you see that T1 is actually being spent on the machine, T2 is used for preparation for that production activity, and T1 is T3 is one-time design activity that you have done. Many times it happens that when we go for mass production, we'll spend 3 months, for example, in designing a product, and later on we'll just plan for each batch. So we'll spend few hours in planning for the batch, and later we'll produce a batch of 1,000 numbers or 500 numbers, and maybe we can plan for a shift also, and the production will happen. Now, when we talk about the smart manufacturing and talking about the customized manufacturing, then certainly you will be talking about preparing a very small batch, maybe 1, 2, or maybe 5 numbers of that. In that case, it's very difficult to afford 3 months of a design time, or a few hours of a batch preparation. So that is how the smart manufacturing is very critical about T2 and T3. So you will be more concerned how you will be able to reduce the 3 months time, so that a unique product can be customized and the design in a much faster way. So these technologies, when we talk about Industry 4 or smart manufacturing, we are more concerned about the technologies T2, because T1 is already being taken care of while the development happened on the automation side. So that is how, once we understand these time components, we will understand what type of technologies, what role of the technologies will be there in the production activity. So that is how we will discuss in the next class. These are the way the different industrial revolutions has been identified, and people have classified that these are the way that the industrial revolution happened. And when we are talking about Industry 4.0, where exactly we are right now. I'm sure that all of you have heard about the Industry 4.0. Can I see the hands? If you can raise your hands, and I'll see that whether you have heard about Industry 4.0 earlier, or you are just hearing first time in the class, it's also fine. I can see only Aman has raised, yeah, Yatin, Naeem, Mohit. Good. Shivang. Anyone else heard about Industry 4.0 before we will be discussing in the next class now? So only 4 people I can see. So it's very important to understand the context of this Industry 4.0. Yeah, Nitin also raised the hand. So but I still found at least only 1/3 people are familiar with the terminology of Industry 4.0. So we'll spend some time in understanding that, because it's very apt and relevant today to understand when we talk about the CAM, and then what exactly is the change happening in the manufacturing. So we'll discuss that part in the next class. So that is all for today's class. If you have any questions, you can just let me know.
So slides can be shared, sir?
Yeah, certainly. So all slides will be shared. I will be also sharing these recorded videos also. So please be attentive on and regular in checking the Moodle website. I will be adding all the content over there itself. And I will also be keep posting you on the WhatsApp group that we have created for the class.